The only thing I would like to say about last night, it was really good on the military. I agree with everything you said about the military part of it. I think you gave a little too much coverage to John Alexander and Eric Davis, and not enough to, because yeah, you gave the impression, or Tim gave the impression, that the physics of the Tic Tacs is beyond comprehension, which is not, as we saw even today from David's summary. The physics is pretty well understood. It's pretty mainstream. We understand how these things work in principle. Making the metamaterial, the engineering, that's going to be difficult. In the same way with nuclear physics, in the same way at the beginning of World War II, when the physicists theoretically knew about nuclear fission, but to actually make a nuclear bomb with requiring the refinement of the uranium isotopes, that was the big hurdle. And also, I guess, the trigger mechanism for the bomb. So, but we're in the same situation today. We understand pretty well the essential conceptual physics, how flying saucers work. I'm talking about the whole flying saucer thing now, not just the Close Encounters with Tic Tac that Mike Turber, you mentioned Mike Turber, Frank, that Mike Turber thinks is fake, but I did agree with what Eric Davis said about Mike Turber's thing. I mean, I don't think it is fake, but in any case, that's my point, that from now on, whenever you're talking about the phenomenon, don't give people the false impression we don't understand the physics. We do understand the physics. We basically understand the physics. Okay, it's not a mystery. It's not a mystery. Now, also where they come from. Oh yeah, one other final point. Then I'm going to shut up. Okay. Well, you're asking what's the motivations? Tim Ventura really wants to know what's the motivations. Well, we have a point of observation. I actually had contact with these Tic Tacs when I was a kid. They told me they were from the future. And they said, well, we're doing now, we're creating them. It's a loop in time. Now, Frank did mention, or was it Tim mentioned, is it Michael Masters, the guy, the anthropologist who's giving empirical evidence of why they're coming from the future? Yes, and that I've been saying that also for many years, because that's what they told me. And I know that sounds a little
Jack, how do you know? Did you saw something or someone called you on the phone? I remember you having a story where some robot called you on a phone.
The
How do
phone.
you what? All right, so that you had this career where you got some black budget money from some
I'm always getting black, but how do you think I lived the last?
Well, like, why? What's the probability that someone in the military contacted you? Why do you trust that?
Because yeah, well, yes, okay, good question, good question. Because in 1953, they told me things that are going to happen in 1973, which happened. Like when I met Hal Puthoff, when I met Russell Targ.
Oh, so like
Edgar
you're saying
Mitchell.
it's more likely that someone contacted you from the future than someone here now,
Well, how in
did
19,
something to.
first of all, you were not alive in 1953. But just as this, you were not alive in 1950. 1953 was a very primitive time compared to now. Okay. So I don't think any of the military officers back in 1953 would be able to predict I'm going to meet Hal Puthoff and other scientists working on UFOs and consciousness and paranormal back in 20 years from then, in 1973, which actually happened. This is all in David Kaiser's book, How the Hippies Saved Physics, right? So it's not just, and also.
What about remote viewing?
Yeah, wait, okay, now, well, wait, let me finish now, because I'm talking about facts, empirical facts, because now if you go to the website SoundCloud, there's actually a recording from 1973 of the actual meeting, a Central Intelligence Agency recording of me back in 1973 talking about the phone call I got in 1953 with Russell Targ and Brendan Reagan. And then Brendan Reagan says, oh yeah, we have all kinds of evidence. We have other kids who have had the same experience. So what the hell's going on here, right? This
I don't know. All I got out of that is the military is talking about getting in contact with you. I didn't listen as very.
Okay, well, you're missing the whole thing.
I'm being playful, but
the point is, there's evidence here. There's recorded evidence. The actual CIA recorded conversation is on the internet. You can hear it yourself. You can hear Jack Sarfati in 1973 talking about the phone call from the computer on board the spacecraft from the future. And you could hear guys like Russell Targ, these are guys working with Edgar Mitchell and the CIA remote viewing project, talking about, oh yes, we know that they're coming from the future. We have all kinds of other evidence, for that.
Okay, and Jack, if I could jump in, I put a link up to that in chat, and I will put that on the website as well when we publish this.
Yeah. So what I'm saying is we have actual, it's like, think like you're a cop, you're a policeman, you're Inspector McGray, studying a murder. You're trying to solve a mystery here. You have to look at every piece of evidence. It doesn't have to be like, straight scientific stuff. You follow your clues. So here we have some, what is called high strangeness that really happened. There's the paper by Jacques Vallée and Eric Davis on high strangeness having to do with the Skinwalker Ranch and all that spooky stuff. Well, here's real spooky stuff. I said I got a goddamn phone call when I was a kid. Now, it turns out there were many phone calls, okay, which I had forgotten a bunch of them. That's another thing. And that's all been corroborated by the actual evidence of what happened. So and the point is, what the phone call said, the basic idea is that I with you guys, other people like Hal Puthoff, that we are creating the time travel tic-tac technology. It's all a self-consistent, what's called a loop in time, which is a well-known concept, from Novikov, self-consistent loops in time, and CTPs, closed time like curves, hypercomputation. Okay, so and then
the conformal gravity fits into that as well, because
I know. Yeah, of course, everything is fitting together. It's all making sense. And the thing is this: see, what I have, which most of you don't have, I'm 81 years old, so I have an institutional memory from the late 1940s to now, which you guys don't have. I see the big picture that you guys don't see, like a detective. You have little pieces of the puzzle. You don't have all the pieces. You don't have the long view, which I have. And now let me say something else. When the CIA, basically started being open with me back in the 1970s, this guy George Koopman, who was a military intelligence guy who was funding us at the time. This is all in the Hippie Say Physics. You could all you could all check this out. David Kaiser's MIT book. They said, okay, what CIA wants to know, how does consciousness work and how do flying saucers fly? That's what they want to know in terms of physics. That was our mission. Okay, that's why I've been getting paid all these 50 years, basically. Okay, and now in the last couple of years, we've actually solved the problem that we're being paid to solve. We've solved, conceptually, there's a lot of engineering, as you pointed out, the metamaterials. But we were tasked by the intelligence services back in the 1970s to work on this problem. And now I claim we've solved it. So that's why it's very important, politically speaking, right now, that when you have Senator Rubio and you have the UAP task force at the Pentagon, that these young schmucks who are in the Pentagon now, who don't know what the hell happened 50 years ago, which I do know, that they should be talking to me to find out about this and not just depend on what Eric Davis and what John Alexander, who doesn't know anything about physics, what those guys, or Christopher Mellon, what they say. They shouldn't depend on that. They should find out what the hell I'm talking about. Okay,
Jack, if I could jump in. Yes. Now you were talking about Frank's stuff. How could you connect your experience to what Frank was writing about in terms of threat potential, I guess? Because I know that you've talked about threat potential also, right?
Well, the threat is obvious. I mean, the threat, okay. And Frank actually said, either you or Frank last night, it's a big universe. There are many intelligences out there with this kind of technology. It's elementary technology. It's not that it's that complicated.
Okay,
Any civilization that learns physics at a certain level is going to get this time travel tic-tac tech. So there could be, and in fact there probably are, there are hostile forces with tic-tac tech out there, as well as our guys from the future. So I mean, it's not just one intelligence out there. I think Frank actually made that point last night, which I agree with. Does that answer your question?
Yeah, no, absolutely.
Are there any other questions, by the way? Yeah, let's try to hear some of those. I'll let Tim kind of direct the questions. I don't know who's muted or unmuted.
Yeah,
I'm
yeah,
just gonna-
I'm still unmuted. Let me go back to Jeremy, if that's okay.
Yeah, I wanted to ask a couple different questions. Back to, this is an engineering conference, so my main interest in this is of course the physics and the engineering. So I want to get back to that and talk about the specifically the type of material. So I have a material scientist that I'm working with, and also a team. We have a team of engineers and stuff. So we're trying to design the material that has these properties. And I know you showed some of those graphs with the different, you know, the different where you sit on that which quadrant you sit on with respect to permeability and permittivity variables, and in two different materials and how they interact. And so I'm kind of like have questions about the materials end of this, and I've been looking at candidates since reading about this and Eric Davis's work on warp drives and feasibility mechanisms for producing negative energy states. And he had referenced, Jack Sarfati's work. So that's how I found Jack's great work on squeeze states. And I noticed that also Wheeler published a 1985 paper on squeeze coherent states and something called the Frank Condon effect. I was wondering if you had ever heard of the Frank Condon effect, because it's sort of that's where I'm looking in the future for the types of materials that I want to design and engineer to, as far as these metamaterials that we're talking about, and talking about building and really building an experiment that we can test these theories with. So I kind of wanted to hear Jack and also or David's thoughts on the materials side of this, and what they have to say.
Yeah, that's definitely a good question. So I don't know specifically what this Frank Condon effect, but I do know that in my investigation of these multiple time dimensions, it actually relates to the squeeze states of light. So there's some other work that looked into the same group, the same Lie algebras that were used for discussing squeeze states of photons are related to the kind of three mass generations I was talking about in this unified field theory model that I'm looking at. So that's the closest connection I personally have as kind of like a particle physicist right now. I haven't really exhaustively looked into the details of these metamaterials, and not even as much as Jack. So, we've actually stayed in brief email contact. I've reached out to you in the past. So yeah, we should stay in contact, and I'll try to look into it more. But I don't really have very specific details to elaborate on.
Okay, do you want me to comment on that too?
Yes.
That's a good question, and that's where the research has to be done. That's okay. That's analogous to saying it's 1941, 42. They're starting the Manhattan Project, and at Oak Ridge they have to. Actually, it was John Wheeler who directed the Oak Ridge thing, where they have to try to find refining and getting the right isotopes for the bomb. Okay. And getting the right metamaterial is like that. It's going to be a major project. It's going to involve, at least dozens, if not hundreds, maybe thousands of scientists and engineers, and that's the big project. I don't have answers, and neither does David. Because it's a major thing. It's like asking Einstein in 1916 to build a lot to calculate black hole collisions that Kip Thorne did like 100 years later. It's a major project. That's the big project.
Right. Well, I don't think we need Einstein. What we need is a Richard Feynman and a von Neumann, if anyone. But I wanted to know if you could comment specifically, Jack, on the coupling and the need for this Froelich condensates, because I know that was a big part of your whole theory on this. Is that Froelich condensates?
The Froelich. Okay.
Talk more about those.
The Froelich condensate. Basically, the Froelich effect. Let's say the Froelich effect. It's a non-equilibrium open system. The system's being pumped off thermodynamic equilibrium, and then you get different kinds of condensates, like superconducting states of different kinds of elementary excitations in the material. Like David was also talking about anions in the edge states, in the boundary states of these exotic materials. What I think happens there is that the coupling, the G over C to the fourth coupling between stress energy sources and the induced gravitational field, that gets amplified exponentially by an exponent e to the Froelich order parameter. See, and that gives like a super amplification to the strength of the effective coupling over above and beyond the ordinary metamaterial negative refraction resonance types effects. There are two separate things going on here. You can get some amplification just using a metamaterial at thermodynamic equilibrium, but when you pump it into the Froelich state, I think what's happening is that you're going to get even a super amplification, so that you could really get warp drive, the Tic Tac propulsion system, with very small amounts of applied energy, which is what we're seeing. It's because that we actually see that in the observations. Am I making sense? Are there questions about what I just said? Do you understand what I'm talking about?
Yeah,
Yes,
yes, that's a decent answer. Anyone?
I was gonna elaborate. So Jack, why did you calculate that you needed terahertz frequency electromagnetic waves? Why did that? What was special about that
No,
frequency range?
okay, that's a good point. No, the terahertz, look, what we're doing, this is like a detective story, right? It's not only scientific deduction, we have clues. The terahertz stuff comes from Hal Puthoff's lecture. Hal Puthoff has access to classified material, right? And Hal Puthoff, you were there in Italy. Remember the talk I gave at the Puthoff talk? It's online. And Hal has a slide of what are allegedly recovered materials from like a flying saucer or Tic Tac. And it says it's a metamaterial, and it has it like resonates with terahertz waves from from just the structure of it. That's where I got terahertz. But also, yeah, I have clues. I'm like Sherlock Holmes here, right? Or also I'm like Paul Hill. Paul Hill, very important. What did Paul Hill do? Paul Hill was not a theoretical guy. He was an aeronautical engineer, and he took evidence from the flying saucer observations, and he tried to build a picture of how one might understand the evidence. This is back in around 1953, about the time I got my phone calls, right? Back in 19. I'm doing the same thing here. Say, look at what the Tic Tac, what they're saying, what Commander Fravor and all these guys are saying it's doing. How can we understand how it works? Now, the other thing is that Stuart Hameroff and people like that, the people working on the consciousness, seem to think that with the microtubules, that terahertz signals in our microtubules in our nerve systems is somehow connected with consciousness, which may be correct. Okay, and remember, when I was the kid, when I got the phone call from the computer from the future, it said it was a conscious computer on board a spacecraft from the future. That's what it said. Okay, so the point is that these Tic Tacs are conscious machines. I think, I don't think there's any biological creatures living inside them, but they have conscious AI. And in order to have a flying saucer or a Tic Tac maneuver, like for example, it's in a dogfight with the F-18, right? It's having you have to be able to compute very quickly. You have to be able to compute how much gravity, how much anti-gravity you need induced in different parts of the fuselage. That's the whole idea of the Alcubierre warp drive. In the Alcubierre warp drive, you have gravity, induced gravity at the nose of the craft, and induced anti-gravity, expanding space, at the tail of the craft. Well, you have to be able to, in real time, dynamically change the distribution of gravity and anti-gravity over different parts of the fuselage. You have to do that very quickly. And we're talking about that's like a hypercomputer. That's like one of these, the closed time, like the CTC computers, hypercomputers that
I don't understand. My question to that is, why can't that be done instantaneously optically using optical materials that effectively work as
I don't think we're communicating. I'm talking about the computations to know how much electromagnetic field to put at different parts of the fuselage in, say, nanoseconds, or let's say even the milliseconds, to keep changing the configuration of the pumping electromagnetic field over the fuselage to keep changing that in real time because you want to make it, okay, suppose,
Isn't that field though an optical field? Isn't it kind of like optical
no, I'm talking about how
information?
to compute. No, we're not talking, you're not following me. What happened? First of all, we're not talking about waves. We're talking about inside the metamaterial fuselage. It's basically what near fields, right? It's like the scalar. It's like what they're near fields. Like it's like
They're not
it's like
transverse waves.
they're not transverse.
They're out of phase.
Yeah. What it's like electrostatic fields or magnetostatic fields, but they're actually they're changing in time. We're not talking about radiation. We don't want radiation fields inside the metamaterial because that's like oil leaking out of the engine. Okay,
Right.
we want to have confined fields. The gravitational field of the Earth is basically a static field. It's not gravity waves. They're static. They're zero frequency waves.
I guess the way I'm interpreting this is as a sort of a physical lens that I can build that warps this or
that may
changes
be,
this
but you have to
refractive
know how to
index.
shape. Okay, use your analogy. You have to know how to keep changing the shape of different parts of the lens in time dynamically in order to.
So I think there's a work in progress that could be done. I think Jack might be putting a little bit of the car. We don't need to get precise control of everything down to the micrometer for gravitation. I mean, the first thing to do is just make sure we can get something where it's stable and it's stationary
Okay, wait,
and it's
wait.
there. No,
Yeah.
just let me finish, right? So we need to figure out how to do that. Obviously, Jack is also talking about the computations needed just to figure out what materials are needed to get here, right? That's a big part of what he's focused on. That's a little bit part of the gap. But I mean, in terms of understanding these effects, first you just need to figure out how am I going to get this thing stationary? Then we can figure out how to get something moving.
Yeah, that's all
you
true.
might not need too much fine precision of, fine tuning of the gravitational field coming out of it, but we do need a lot of work to figure out, okay, how do we compute? We need to figure out how to actually compute these refractive index properties, right? Like you can ask me like, well, what about this effect? What about that effect? What about this effect? I mean, it's hard to have an answer unless you just sit down and do all these calculations. So we need to have more people that are directing their thought to understand, okay, there's all these different exotic effects. Maybe, pulsed metamaterials with Froelich pumping, maybe that's one way to do it. Maybe there's other ways too, right?
No, there
So we
aren't
need to-
any other ways. I don't think
I have no idea, right?
Yeah, but I
So-
do have an idea. Okay, but there are two separate problems. What Dave you were talking about right now in the laboratory to actually start designing, doing experiments. Yeah, everything you said is true. I was talking about something else. I was talking about the actual advanced intelligence out there that's contacting the Navy, in these close encounters, what they have on board. This I'm getting back to Frank Milburn's best, his Sadat position paper. What they have on board is a very powerful conscious computer that is computing in real time, dynamically, how to configure the warp field so it flies in the direction they want it to fly. See that
But that
requires-
might not be the thing that we should focus on because that might
Why
not be
not?
the first
Because,
thing.
well,
Well, I
I'm-
mean,
well,
Right,
I-
there might
we
be
gotta build
a
up to
more
that,
preliminary
there
step
could be
that
some
we can
stepping
test.
stone.
No,
right?
I'm talking about right now. I'm talking about for the Pentagon to know what the hell is needed. Okay. You're
And
being
also,
too
when you say
academic.
when you say a conscious computer, I think of this entity as being conscious, but we only see with our two eyes. This thing would have to see in all directions, all around it.
Well, yeah, it has senses all around. Of course, that's correct. That's absolutely correct. That's what happened.
If I could jump in really quick,
Sure.
Sean had a question, I think also.
Yes.
Sean, if I could squeeze
Yeah, I
in.
was just my question is for David. I was wondering if you ever heard of Frank Zadarsik.
I haven't, sorry.
Oh,
Do you want to
okay.
briefly mention anything about what he did? or-
Yeah, actually, I'll ask him.
Okay.
I'll ask that later. But anyways, have you ever heard of Eric Dollard?
Oh, yeah. He did some interesting electromagnetic experiments looking at Tesla patents. Yeah. So that's kind of getting into some of the near field effects. He claims to have some faster than light measurements. I know
Oh yeah,
that
and not just
Wheatstone
that.
also
Yeah,
did
not
in the
just
1800s.
yeah, not just that, but he has he claims he just completed Heaviside equations. So
Okay.
I suggest you take that up and maybe you could play with that for a bit. And
Yeah. I mean, I there's something that I've looked into a lot, actually. I've looked into so many claims of people claiming they've gotten Heaviside gravity to work, and I just haven't found anything yet. So
Well,
I'll
not
look
on
into it.
gravity. Yeah, I don't think it was just gravity. I believe it was just like he completed his math that no one else could. He claims. But anyways, that's just food for thought. But
Appreciate it,
Frank
yeah.
Zadarsik, I believe he has some awesome math on being able to figure out the what was called the quantum transition, where the electron moves from one orbital to another. He
Okay.
claims he has the math to that, and he put the I believe it was the spring constant into the Coulomb's equation. I'm not too sure if that's exactly
You
how
know,
it went, but
this is really not.
Well,
I
yeah.
don't know.
anyways,
Quantum fields are
just,
based off springs, so
yeah.
I don't know.
Anyways, that's just it's just for food for thought. Anyways, take care.
Okay, thanks,
thank you,
Sean.
appreciate it.
Let me go to Jeremiah next. Jeremiah is waiting.
Yeah, I've got a question for David. Sorry, Jack, but David's the young guy that's gonna have to live on to carry on these ideas. So I got a question for him and get his mind going on all these metamaterials.
That's true.
Yeah, you did bring it up, David, about metamaterials. So I have to ask on the engineering and practical side. Let's take a look at one of the earliest metamaterials ever made, right? The split ring resonator array.
Right.
And so the interesting thing that you mentioned about near fields, and if you take a look at the negative refractive index of split ring resonator arrays and how they can appear transparent to certain frequencies, it's kind of odd, right? Because in order for those materials that are physical and dimensional to appear transparent, they would have to theoretically have a velocity of light going through them, or have the electromagnetic wave entering them travel faster at one point of its transition and travel slower than light at another, in order to exit the opposite side undistorted, so that that material would effectively disappear to the EM wave. Which makes me think about the interesting phenomena of what happens in the near field right at the surface of a split ring resonator, or even a churro split ring resonator, where you have a ring inside of a ring, the two being at slightly different frequencies, but having a very sharp spike harmonic that occurs at the node between the two frequencies. So if we have other materials that maybe have interesting properties, interesting atomic properties or molecular properties, and we place them in the near field of that resonator, could we not entrain those materials and really electromagnetically move them around, screw with them, change their precession atomically, or do things like that by using the near field effects of these nanomaterials, or of these nanoresonators?
Yeah, I mean, honestly, I would have to look into the more of the details of what you described and try to get down and dirty and do calculations. It's difficult for me to just give like quick yes or no answers, but no, I mean, that sound very interesting. And I think you're kind of thinking about the right things. I mean,
I
looking to
agree,
near
by the way.
fields
I agree. I
Yeah.
agree with that. Yeah, these are the
We're
kinds of
attempting to play with the concept. It's complicated, but we're attempting to design something now, and we're gonna take some measurements and see what we get. Honestly, I think that we're flying in the dark. I'll be the first to tell you I have no idea what I'm doing, but I am reading papers and attempting to understand it.
Okay, let me give you
Definitely,
a general.
that sounds interesting.
Let me give you a general idea here, because this is important. That hasn't been mentioned yet. Well, no, actually, David, you mentioned very briefly. In order to get anti-gravity, I'm talking about now at the practical, the practical tic-tac level. What matters is the dissipation. It's the phase shift. Dissipation in the metamaterial determines the relative phase shift when you have if you apply an electromagnetic field in the metamaterial as the pump, and it induces a gravitational field as the output. So electromagnetic field input into the metamaterial as the transducer with a gravitational field output. The dissipation changes the phase relationship between the input electromagnetic field and the output gravitational field. That's that cosine theta in the equation, in my equation that David wrote down. When that cosine factor, when the phase factor goes from a positive cosine to a negative cosine at a little place in the fuselage, it switches from an attractive gravity field to an anti-gravity, to repulsive gravity field. So in order to make anti-gravity, it's just a matter of dissipative phase shifting. Electrical engineers, we're talking about phase modulation. Each little, just think of the flying saucer fuselage as a kind of lattice work, as a kind of a tiled lattice work, and each little spot on the lattice can either be a attractive gravity field, I'm talking about near fields, attractive gravity field or repulsive gravity field, depending upon the relative phase of the electromagnetic field at that spot compared to the output gravity it's generating. Okay, and that depends on how much dissipation there is compared to non-dissipation. Okay, dissipation in material is from inelastic scatterings. Okay, and in terms of electricity, it's like resistance versus reactance. Okay, see what I'm saying? It's the ratio of resistance to reactance, and so that's what you want to control on a micro scale. You want to control that. Thing. Okay, are you getting what I'm trying to tell you?
Yeah. I mean, it gives me this idea about a phase conjugate mirror type system where you actually reflect a wave out in both directions, but one of those sides is interacted with. You perfectly bounce back your wave because this metamaterial has the ability to absorb it and reflect it back at the same angle it came out. And then you could effectively push back against the field that you just created within unenclosed space and create a force that would not be equal and opposite because it's time delayed.
No, that's not quite what I mean. But see, I think in terms of the actual equations, and you're thinking in terms of physical pictures.
Engineering. I'll admit I'm an engineer all the way, through and through.
Okay,
so.
but don't think of waves. I'm thinking even of like applying voltages. I'm talking about induction fields, near fields. Okay, just think of a capacitor. Just think of a capacitor, LCR network. Okay, a capacitor with a coil wrapped around it, that sort of thing.
Fields.
And it's just by changing the voltage, by changing the input voltage, you can change the input. Okay, just think of a simple capacitor, of electrostatic field between the parallel plates of the capacitor, right? And that electrostatic field will generate a gravitational field according to Einstein's field equation. Let's just think of that.
That's
simple.
interesting. That makes a lot more sense about the high frequency gravitational wave detector that we were talking about last time.
Okay, right now I'm just thinking almost DC. Let's forget waves. Let's just think that I have a voltage across a capacitor and I'm slowly changing the voltage in time. That's going to, and that will generate a gravitational field. But
so is it the rate change that creates the gravitational field? The actual change in potential is it the change in potential between the plates that creates the field, or just the static potential between the plates?
No, the static potential is the electric field, right? The gradient of the voltage. Okay, the electric field in the capacitor is going to generate a gravitational field according to Einstein's field equation. Now the problem is,
catch that. That's interesting.
All energy sources gravitational fields, and this is neglected. This is always neglected, right? So in quantum field theory, you just study everything in flat space-time and you put all the matter in, but really gravity, right? Any energetic thing is going to warp space-time. So
yeah. So here's the thing. So now let's be very specific. We're just going to talk about a battery connected to a condenser. Okay, but that condenser is filled with a special kind of metamaterial. All right. That's the picture. Let's make it as simple as like the hydrogen atom, as simple as possible situation. Okay, so we apply a voltage to that system. Applying the voltage is like pumping the system. We apply a voltage. That voltage generates a gravitational field inside, in the material between the plates of the capacitor.
E equals mc squared.
That equals, yeah, well, that's true, but that's not.
No, but it's like it's the C in it is you're just pumping light into the system in electromagnetic fields.
Okay, wait. I'll give you a simple way for engineers. Einstein's field equation is just like Ohm's law. We all know Ohm's law, right? Ohm's law, the output current is the applied voltage divided by the resistance, okay? You can think of Einstein's field equation that way. The voltage is the stress energy tensor. 1 over the resistance is the coupling constant, G over C to the 4, and the current is like the gravitational field. This is an analogy, okay? This is an analogy. So the point is this, what you want to do, what the metamaterial does, it makes a very small resistance for a fixed voltage. For a fixed voltage across the capacitor, if you're somehow able to control the resistance and make the resistance go to 0, like in a superconductor, so to speak, you get a very big current output. The current output is like the gravitational warp field. So that's the basic idea. So the metamaterial is a way of getting, in this analogy, very small resistance. That's low power warp drive. That's what we're aiming for. Okay, does that make sense?
Yeah, I did have another question for you on the experimental side of just this capacitor, though. If you had, let's say, a theoretical 1 million K factor in possible dielectric that you could put, you could put a few 100,000 volts in 1 millimeter, and you were to measure, say, gravity distortion around that capacitor, would you be able to measure it?
Well, okay, that's a good question. That's a good question.
Because I guess what I'm asking is, you're taking electrons from one plane and you're putting them on the other. You're just moving them from point A to point B, but they're technically still within the same device. So you have the same amount of total energy in the system. I guess I'm confused by why the separation of the positive and negative charges equals a gravitational field.
I don't think, all I'm doing is look at the mathematics of Einstein's field equations, okay? And now you did say, the thing is this, now, so you said if the K factor is what, 10,000?
But let's say it's a million, because we already have 200,000.
Yeah, right.
K
If
factor.
it's a million, yeah, if it's a million, let's see, and I think that I think that will increase the efficiency by a million times, by 10 to the 12. I think goes as the square. Does it? Let's see. Yeah, because c squared is 1 over the dielectric constant. C squared is 1 over epsilon 0 mu 0. So if your epsilon is increased by a million, and the coupling though goes as the 4th power of the speed of light. So okay, if you give me a dielectric constant of a million, the gravitational effect is amplified by a trillion, by the basic square of that.
Wow. Okay, did not expect that.
According to Einstein.
Okay, so let me jump in really quick. Let me go to Todd next. Todd, you there?
This time.
There we go. I just
there he is.
Okay, hit the wrong button. Hey, so on this metamaterial stuff, I'm working from the engineering side. I don't know if you're familiar with any of my work. Todd Desiato. No.
Sorry.
The name is, yeah, we know your name, but no, I don't know what.
All right. I published a paper 2016 and in 2018 about an engineering model of quantum gravity. And in that model, it's not at all really different from what you've been presenting. What you call spin density, I just look at QED and at the Compton frequency, the Compton wavelength. You have breakdown and you have exchange scattering with the vacuum. So that becomes your finite radius. Basically, have you considered that the scalar magnetic field is the scalar field you're looking for? Because in your Jack's equations, you want M, you want a strong magnetization, and you want a low speed of light, which you're going to get with a material that's got a high magnetization like ferrous materials. And then you have, you can induce in such a material Larmor precessions. And you can do this, say you have a sphere as your bubble or your hull, your metamaterial is this material that then you project onto this material a magnetic field that varies from point to point on the material, so that over here in front you have a strong magnetic field and in the back you have a weak magnetic field.
Yes,
and
something like that could work.
RF signal that causes that area of the hull to resonate.
Yeah. It's something like that, roughly speaking. Roughly speaking, yes. Okay.
Yeah, and to elaborate, so there, you talked the Cartan radius that I discussed is actually slightly different than the radius you were discussing. So Poplawski actually has a torus for his model for the electron because it actually has 2 radii. So it's something similar, but it's a different radius for the gravitational aspect. So I'm just pointing that out. So there's kind of like this electromagnetic radius and then a gravitational radius. So what you're describing may be somewhat similar, but yeah, there's just that small difference there. To really answer your question, though, you mentioned this magnetic scalar. I don't know exactly what you're referring to, but I have looked into, people talk about scalar waves and longitudinal modes and things like that. There is, for example, below the electromagnetic potential, there are these Whittaker potentials or Hertz potentials. I've studied these a lot. There is this scalar field that's related to the Lorentz gauge condition. that is more an electromagnetic scalar. And typically the mathematics, you could imagine such a magnetic scalar. I don't even know if this is exactly what you mean, but the mathematics typically forces that to 0. But if you had magnetic monopoles, you could cook something else to get it. So that's the closest guess I can get at what you might be referring to, but I'm not sure the precise details of what you're referring to.
Let me say one thing. Keith Wanzer, I don't think he's here. Keith Wanzer actually did a computation of my equation there for just a simple material, a homogeneous material, and it turns out that the magnetic permeability appears in the effective coupling between stress energy and induced gravity has the magnetic permeability in the denominator, so that diamagnetic materials like superconductors, see, this should actually give a strong induced gravity field. So that would tie in a little bit with the Modenese work and the Podkletnov, whatever.
Yeah.
Yeah, and it would do the same thing as a hull. Because
we're talking about the hull. We're talking about a hull, a metamaterial hull, where it goes diamagnetic, and so if you have a diamagnetic fuselage of the Tic Tac, then that would have the effect. And then you just, in order to get gravity versus anti-gravity in different parts of the hull, that's just a matter of changing the amount of dissipation compared to reactants. Just the phase shift, the cosine theta in my equation. It's phase modulation. It's the cosine.
Negative.
Okay.
Sorry, can you repeat that, Todd?
He said, as long as you don't go negative. If the cosine theta goes negative, then that equation violates the strong energy condition.
Forget that strong doesn't mean shit. I don't care about that.
In every general relativity textbook.
You don't understand what the strong energy condition. It's just strong energy condition means that there's nothing that says you can't violate the strong energy condition. It's not a law of nature. It's just that in order to get a warp drive, you have to violate it. So okay, but we're seeing the warp drive. The warp drive is a fact.
You don't.
There's nothing sacred. There's nothing important about the weekend. It's just a condition. Okay, it's just a constraint, but it's not a law. It's not, nature doesn't have to obey the strong energy condition. God did not say that. It's a matter of empirical observation. Here's the general point.
I've never observed any.
What? Yeah, well, no, but we have. Well, you got your.
That's what you ask, I guess.
That's what flying saucers are. They're violating the weak energy condition.
I think an important key is to study the more exotic theories than general relativity and to look to see what happens to that strong energy condition in metric affine gravity, and things will change a little bit. So if you stick to pure GR and you stick to Einstein's field equations exactly how it's written, and you really stay closed-minded and don't think about what's going on, it's easy to get caught in that paradigm. So that's why I mentioned the metric affine stuff, because it has that scalar field that is somewhat similar to what Jack is talking about. And I know it does change a lot of the energetic stuff that's going on in comparison to GR. So something to consider.
Yeah. And the point is the cosine going negative is exactly what you need in order to explain the observations.
Yeah. Otherwise, like if what you're claiming is true, then the whole thing breaks down. It's impossible, as Jack is saying. So yeah.
Yeah. So here's the point. Let me get this very clear. If you see a Tic Tac or a UAV going at, say, 10,000 miles an hour, and then it makes a sharp U-turn where it looks like there are thousands of G's involved, that's warp drive. The only way to explain that is what we're talking about. Because what happens inside the Tic Tac, it's 0 G. The actual they don't feel any G forces. It looks like, to the outside observer, it looks like there are G forces, but they aren't there. That's an optical illusion. That's part of warping space-time. That's what warp drive's all about. So everything that Commander Fravor and Kevin Day and all these guys reported in the 2004 encounters and the 2015 encounters with the battle groups, that all, unless it's something like what Mike Turber's talking about, where he says that that's just spoofing electronically, they're somehow tricking the electronics. But if it really is what it appears to be, that's definitive proof that it's a warp drive. Has nothing to do with conventional propulsion. There's no thrust Zero trust.
Jack, let me jump in with a question really quick. Now, so with the model that you've come up with for the Tic Tac propulsion, from what I understand, they are transitioning between ocean, atmosphere, and presumably space, right?
Yeah.
So how do you think that this would work? I mean, would you expect any drive issues or anything like that during a transition when they're going into or coming out of the water?
Well, it doesn't matter what I expect. It's what we see. These things are doing it. And we don't know enough of the details without working on it, like a Manhattan Project scale to answer a detailed question. But clearly, let's just assume that the observations are true, okay? So these Tic Tacs, they go 500 miles an hour under the water, right? And then they just pop out. And Hal Puthoff even reports that they may be able to go through solid matter, right? That's how, I'm not saying that, but Hal Puthoff and Eric Davis, they're talking about that kind of stuff. All that stuff, though, can be understood in principle on the basis of the equation, my equation with the cosine theta that that Dave put in that slide. That equation, essentially, qualitatively speaking, explains everything, even time travel. Even allows time travel through closed time-like curves.
Well, now I guess this goes back to the idea of the threat, and I'm probably going to get myself in trouble by asking, but with these kind of capabilities, what would you propose for some kind of defense against these? How would you circumvent that drive, or how would you shoot one down, basically?
Well, that's a good question. It may not be possible. See, one of the things that's where I'm working with I'm working with a guy in the Italian Air Force back in Cortona, in Tuscany. This guy Saro, he's a Italian Air Force military intelligence, and it may not be possible to defend against, because it may be possible to create what's called like an artificial white hole, like a defensive shield. It's like the event horizon of a white hole, so that any object that tries to get close to it is infinitely repelled, can never even reach it. So in other words, you could have, the old science fiction force shield. It's possible with the equations that David, my equations that David has simplified and wrote down there with that cosine thing. Okay, all kinds of weapons systems, both offensive and defensive, are possible. Now the thing is this. Before, the Russians have interviewed me on all this. Let me tell you a little background as to what's going on here. I first gave these ideas in a very primitive, rough form in 2011 at a DARPA NASA 100-year Starship meeting. Eric Davis was there. Eric Davis didn't understand it. He sort of poo-pooed it at the time. But I gave this basic talk with metamaterials and low-power warp drive. This way before Tic Tac. This is in 2011. And of course, the Russians were there. The Russians are not stupid like our guys. Our guys are kind of stupid compared to the goddamn Russians. They're smarter. So the Russians were there at this meeting that I gave an invited talk. The talk was paid for by NASA. General Pete Worden, who was formerly head of the U.S. Space Command. He was heading NASA Ames. And I was working with guys at NASA. So they paid my way to Orlando, Florida. I gave the damn talk. I started talking about UFOs, and they didn't like it there. And in fact, Sharon Weinberger, who's a defense journalist, actually wrote an article in BBC about this meeting where I pissed everybody off. I got people screaming and yelling because they started talking about UFOs. Okay. So in any case, the Russians were there. The Russians take me seriously. So around 2014, I get a phone call from Vladimir. He says, Vladimir, we are from St. Petersburg Channel 5, and we would like to make a video of you. Okay. So, okay, this is San Francisco. So Vladimir and another guy, I have this all photographs of them. They come and we spend a couple of hours videoing me, talking about all this stuff, all my crazy physics ideas, UFOs, the whole thing, right? So this was like 2014, 2015. And they said they would send me the video of it. They would send me the program. I never got the program, never saw the program. But a few months later, Vladimir Putin comes out with this whole big thing that how Russia's going to get teleportation, all these advanced quantum technology weapons, just this kind of stuff that I was talking about to the Russians. Okay. All right. So
Jack, there's a couple other ways that the Tic Tac could be doing those 90-degree turns at like 10,000 miles an hour. Have you ever considered
Yeah.
the possibility that they can control the inertial mass of the craft, make it?
No, that's bullshit.
zero?
Okay, okay. I'm glad you said that. Right away, that's bullshit. As soon as I hear that, that shows you don't understand basic general relativity.
I know you say that to
cannot-
everyone.
You cannot change the inertial mass. It doesn't do anything. You don't understand the
Where
equivalence.
does the inertial mass come from in the first place? If you can't answer that
No, no,
question,
first of
you
all,
can't, say you can't remove it.
Okay, first of all, there's a little book called Just Six Numbers by Sir Martin Rees, British astronomer, real master, Stephen Hawking's boss. And he talks about if you try to change the inertial mass by even a small percentage, you blow up the fucking universe. Okay, that's the stupidest idea I ever heard. Now, unfortunately, even Hal Puthoff has pushed that idea a little bit, and it's really stupid.
Okay.
It violates elementary physics. Okay, there's no way to change it. And even if
It
you
doesn't violate quantum field
Wait,
theory.
let me finish. Let me finish. Even if this is an elementary physics 101 lecture, okay?
The next lecture is actually
Let's-
about getting
shut
inertial
up
mass.
and let me talk. Let me talk, okay? Shut up. Young, okay, let me talk. Respect your elders, young man. Okay, listen.
Well,
If-
elders in age, not in
Hold
intelligence.
up a minute. Shut up. If you change the inertial mass, that means you make it like a photon.
Hey, Jack, what are all the masses of the particles in conformal gravity?
Pardon me?
What are all the masses of all the particles in conformal gravity at high energy?
Is it, but zero.
Oh, wait, how did it go to zero?
No, but that's just a mathematical thing. The point is,
No, it's just a
haven't you read-
mathematical thing connected to a scalar field. You're right.
No, yeah, but you don't change. If you change the scale of that, Lenny Susskind, read Lenny Suskind's book. He said, if you try to change that scale of field, you're going to blow up the universe.
You have mass renormalization in quantum field theory. It looks like we need to figure out renormalizability
not
of gravity, and
Let's not get too
maybe
complicated.
inertial mass is related to
Wait a
that.
minute.
I don't know though.
Yeah, but just a minute.
Just a
a-
thought.
First of all, you don't change the mass of the ship. That's impossible. You don't change the mass. And even if you could change, it wouldn't help. It wouldn't change anything.
Impossible is a very dangerous word.
No, you don't see. You don't understand. Look, I understand. You understand certain engineering. You understand parts of physics, but you do not understand the part of physics relevant to that question because it's a totally crazy, stupid thing to even suggest. And even if you could do it, it wouldn't help.
Well,
Wouldn't help.
if it's okay, let me jump back in. Then you were talking about the white holes, and I'm going back to the weapons part of it. So if you have a metamaterial covered hull, if you were able to ablate part of that hull, or perhaps even just darken it, damage the metamaterials, would that create kind of like a pinhole leak that would cause the vehicle to destruct?
Oh, sure, yeah, of course, yeah. Yes, but the thing is, I see what you're saying. Can we shoot down a Tic Tac? Yeah, well, maybe that happened at Roswell in a few cases where they shot down flying saucers just with BB guns. No, that's possible. But the thing is this: if they want to, if you have a Tic Tac with that kind of technology, you can create a white hole kind of shield around it so that couldn't happen. If it's switched off, of course, you could destroy it. It's delicate. See what? Yeah. So it just depends on, maybe they switched off their cloak field. They switched off their, it's just like Star Trek. They switched off the shield. If you switch off the shield, yes, you could destroy it.
Well, and the reason I asked was, and again, I'm very ignorant on this, but my thought was, everything that I've seen so far, like when I interviewed Frank, he had talked about soldiers popping off rounds with their rifles and stuff like that. It seems like a kinetic weapon would be too slow. And if this thing is able to go through water, maybe even land, like Hal has said, kinetic weapons probably wouldn't be the way to go. But
No, we
some
don't
kind
know
of a
that.
beam
But
weapon.
It
Kinetic
depends
weapons-
on the precise details of how that craft is operating. I mean, if it's perfect and it's doing perfect anti-gravity, then that really implies that no energy can get in. So I think you would basically have to be able to figure out how to do like quantum cryptography on space-time at that point to figure out how to make a weapon to like penetrate that, because you can't even use classical energy to like get in there.
Oh,
But
you
maybe
can't put photons on it. You're saying the photons would just go around because it's like a point
I mean,
particle.
if the thing is literally cloaked and invisible, it depends on the details of the field profile around it, right?
Let's put it this way. What's clear is that if with our conventional forces, if there's a hostile force with tic-tac tech, they're going to kick our asses and we can't do a fucking thing.